Hello everyone. Hope you are good in health. Let us start today's session. In our previous session, we learnt about Ohm's law. Now today, let us first understand activity 12.2. That is on page number 205 in your textbook. Take a nichrome wire, a torch bulb, a 10-watt bulb and an ammeter. It is up to range from 0 to 5, a plug key and some connecting wires. Now again you need to recall what is a nichrome wire. Nichrome is an alloy of nickel, chromium, manganese and iron. It is combination of these metals. Then we have to take a torch bulb as shown in the figure. Then a 10-watt bulb. Watt. W is symbol of watt, which is unit of power. We have already studied about power in standard 9. Okay. And here it is given a torch bulb. Now a torch bulb will provide a power of nearly equal to 1.25 watt. So we have a nichrome wire, a torch bulb which give approximately 1.25 watt power, then a bulb of 10 watt power, an ammeter which has 0 to 5 ampere range, a plug key and some connecting wires. Now refer to figure 12.4. What do we have to do? We have to set up the circuit by connecting 4 dry cells. Combination of cells, what it is called, a battery of 1.5 volt each in series with the ammeter leaving a gap xy in the circuit. In the figure you can refer how it is set up. There is a battery which is a combination of 4 dry cells. With that there is a key which is represented as K. Okay, and then there is a gap xy. Now complete the circuit by connecting the nichrome wire in the gap xy. So first thing what we have to do, we have taken nichrome wire. So first case what we will do, we will connect this nichrome wire in the gap xy. Then we have to switch on. And then we have to take reading from ammeter. What type of reading it will show? It is ammeter. That means it shows electric current flowing through the circuit. Afterwards, we have to take out the key from the plug. That means we have to switch off. One note is given that always take out the key from the plug after measuring the current through the circuit, which means whenever we are changing anything in the circuit, we need to switch off first, then the changes we can make. Then what change we have to make now? Replace the nichrome wire with the torch bulb. This means the reading we have taken from nichrome wire, how much current is passing or how much current is flowing through the circuit when we have connected nichrome wire. Now we will remove nichrome wire and we will use a torch bulb. So we will connect a torch bulb in the gap XY with some connecting wires. It has to be connected. And then what we will do? We will switch on and then we will note down the reading of electric current flowing through the circuit. Where will it be shown? In the ammeter. After noting the reading from ammeter, again we will switch off and then we have to repeat the steps with 10 watt bulb. This means we will remove a torch bulb from XY and then we will connect 10 watt bulb in place of XY in the gap XY, and then we will switch on and again we have to note the reading of electric current flowing through the circuit. Then we have to observe the electric current the values of electric current which we got in all three cases. We will observe through this activity that the current is different for different components. This means when we have connected nichrome wire, that time the value of electric current is different. When we connected a torch bulb, that time also value of electric current is different. And when we connect 10-watt bulb, that time also the value of electric current is different. Why are they different from each other? So the answer is certain components allows easy flow of current through them. This means some of the components allow electric current to pass easily from them, and some of the components resist the flow of current. This means some of the components will stop, or we can say resist, the electric current flowing through them. And we already know electric current, that is the flow of electrons, that means the motion of electrons. When we say there is electric current, it is the movement of electrons. So the electrons are not completely free to move within any conductor. Some of them are restricted, that means they are resisted by attraction of the atoms among which they move. That means, for example, take a nichrome wire. In that, there are the atoms which can attract the electrons flowing through it. So that is why you need to remember that some of the components allow the current or the electrons to move easily through them. So we can say they allow easy electric current flow. And some of the components are there which do not allow easy flow of electrons. That means they resist the flow of electrons, which means they stop the flow of electrons, the movement of electrons. Now, a component that offers a low resistance is a good conductor. Now, we all know what is a conductor, right? Which allow electricity to pass through it. That is called a conductor. A component which offers a low resistance is a good conductor. It is very much true, right? Which offers low resistance. That means it resists very less. That means it allows the electrons to move through it easily. That is why it is a good conductor. And a conductor which have high resistance, it is called a resistor. And it is a poor conductor. Now how is this? When any conductor will have high resistance, that means it will resist, it will stop the motion of electrons in more amount. That is why the electrons will not move easily, and that is why it is called a poor conductor. Remember these two things. Why it is called a good conductor? Because it provides less resistance. That means it offers very less stop to the movement of electrons, which means the electrons can flow easily. That is why it is a good conductor. And why the components are called as poor conductor? Because it provides high resistance, which means the resistance, it will stop more movement of electrons. That means it will not allow electron to move easily through it, and that is why it is a poor conductor. Even an insulator offers high resistance. What are insulators? We know insulators are like components which do not allow electricity to pass through them. So they offer high resistance. That means they resist the motion of electrons, which means they resist electric current. So from this activity, we learned about a good conductor and a bad conductor. A good conductor will provide less resistance and allow electric current to move easily, and a poor conductor will be providing high resistance, which means will not allow electric current to pass and to flow easily. So this is all about activity 12.2.